Hey everyone, and welcome. So, if you're a Python developer working in the AWS world, you've definitely run into DynamoDB. But let's be real, the big question is, are you using it in the most Pythonic way you can? In this explainer, we are going to break down exactly how to master its core operations for code that's not just functional, but clean, efficient, and ready to scale.
So, here's what we're going to cover. First, we'll get the big picture of what makes DynamoDB tick. Then, we're diving deep into the two main ways you get data out, the query and the scan. After that, we'll put them head-to-head to see when you'd use each one. And finally, we'll wrap up with the essential toolkit for actually manipulating your data.
Okay, let's jump right in. Before we even think about writing a single line of code, we have to get our heads around the fundamental design of DynamoDB. You got to understand what makes it so different from a classic SQL database you might be used to.
Now, the keywords on this slide really tell the whole story. Serverless. That means you're not managing servers, no patching, none of that headache. Key value tells you it's built for one thing above all else, grabbing data super fast when you know it's key. But that last part, that's the real showstopper. Single-digit millisecond performance at any scale. That's the core promise, right? Your app should be just as snappy with a petabyte of data as it is with a tiny gigabyte. This right here is the fundamental question at the heart of any database. How do you find that one specific record, that one piece of info, when it's buried among millions or even billions of other items? Well, DynamoDB gives us two very different tools for the job, and they have completely different philosophies.
All right, let's start with the first tool, and honestly, the most important one in your entire arsenal. This is the one you want to be reaching for pretty much all the time. It's the query operation. Think of it as your surgical scalpel.
So what's the secret sauce that makes a query so fast? It's not just searching around randomly. The deal is you have to give it the main key, what we call the partition key. A great way to think about it is like a street address. DynamoDB uses that key to go directly to the exact physical location where your data lives. There's no guesswork. It's that direct, targeted lookup that makes it incredibly fast.
Okay, but what if you need to find a user by their email address, not their user ID? A normal query can't do that. And that's where indexes come in to give your queries superpowers. A global secondary index, or a GSI, is basically a replica of your table, but it's organized by a totally different key, like that email address. This lets you run those same, fast, targeted queries on other parts of your data. And a local secondary index, or LSI, just gives you a different way to sort items that share the same partition key. It's all about creating multiple, high-speed ways to get to your data.
All right, let's switch gears and talk about our second tool, the scan. And you'll see it's a completely different animal. If the query is a scalpel, then the scan is a giant sweeping searchlight.
And yep, that analogy nails it. A scan literally starts at page 1 of your table and reads every single item. It goes one by one until it either finds what you asked for or it hits the very last item. It's super simple to write, but as you can probably guess, this brute force method has some major consequences.
This slide right here is the big blinking warning sign every developer needs to see. Because the scan reads everything, it's not just slow, it can get insanely expensive. You pay for every item it reads, even if that item doesn't match your filter. A single poorly placed scan in your production app can absolutely torch your provisioned capacity, slow everything down to a crawl, and hand you a shockingly big AWS bill at the end of the month. Use with caution.
Okay, so we have our precise scalpel and our powerful but very expensive searchlight. The big question is, how do you decide when to use which? Let's put them side by side and see. This chart really is your cheat sheet. And the takeaway is super simple. Your default thinking, your first instinct, should always be, how can I solve this with a query? You should be designing your data models, creating GSIs, basically doing whatever it takes so that your main application can use queries. A scan isn't just a last resort. It's a tool for very specific non-critical tasks, like a one-time data export or maybe an admin script on a tiny table. If a scan is a core part of your app's logic, it's probably a sign you need to rethink your data model. Okay, so finding your data is half the battle. Now let's talk about the other half, creating it, changing it, and getting rid of it. We're going to walk through the absolute must-know tools for data manipulation.
So adding data to DynamoDB is going to feel incredibly Pythonic because you're literally just working with a standard Python dictionary. You build out your data in a dict, you pass it to the putItem method, and that's it. The SDK handles all the messy stuff for you. Now, one key thing to remember here is that putItem is what we call an upsert. It will either create a brand new item, or if an item with that same key already exists, it'll just completely replace it. Now, update item is where you get to be really surgical again. Instead of rewriting an entire item just to change one little thing, you use something called an update expression. This lets you define precisely what you want to change, maybe just adding a value to a list or incrementing a number. This is incredibly efficient, and it's fantastic for things like atomic counters. It guarantees that even if two people try to update the same counter at the exact same millisecond, no data gets lost. It's a really powerful tool for building solid apps.
And when it's time to remove a bunch of data, please don't do it one by one. The batch write item method is your best friend here. You can bundle up to 25 delete requests into one single network call. That is way more efficient and faster than making 25 separate trips back and forth to the database. It is the absolute key to doing bulk operations the right way.
So if there's one thing you walk away with today, let it be this. DynamoDB isn't a database you can just kind of wing it with. It really rewards you for being intentional with your design. True success comes from a mindset shift. You have to think about your access patterns first, preferring a query over a scan, using update for targeted changes, batching your writes. These aren't just best practices. They're the fundamental building blocks of a fast, scalable, and cost-effective application.
And that brings us to our final question, which is really the heart of it all. We've seen the right tools to use, the query, the update, the batch operations, but the real art is in using them with elegance. So what's the most Pythonic way to get your data? Well, it's about writing code that isn't just functional, but is also clean, readable, and most of all, efficient. That's what separates the beginners from the experts. Thanks for tuning in.